Yes, students, today we'll start with the lab experiment. Okay, that is analog circuit lab experiment 18 ECL48. In previous class video, we completed 3 experiments in part B, right? So next we'll move on to the 4th experiment, that is monostable multivibrator using 355 timer. Okay, what is the name of the circuit now? Monostable multivibrator using 355 timer. Again, there is a second question here, that is astable multivibrator using 355 timer. Okay, today we'll discuss about only monostable multivibrator using 355 timer. Understood? First, you take 355 timer circuit diagram here. This is the IC pin. Okay, this is the IC here. Total there are 8 pins here. Okay, pin number 1, 2, 3, 4, then 5, 6, 7, 8. There are 8 pins are connected in the ICs. Okay, so inside the IC, they have taken circuit diagram here. Okay, here they have taken 2 comparators, 1 flip-flop, 1 output buffer, 1 transistor, and 3 resistors. These are the elements that have connected for the 355 timer. Okay, first they have taken 3 resistors in series. It is connected between the pin number 1 to 8. Then they have taken transistor here, NPN transistor. It is connected between the pin number 1 to 7. Again, they have taken 2 comparator here. Okay, so one is for the 5 kilo ohm, the another comparator input is connected to again 5 kilo ohm. Okay, because voltage is flowing from where to where here now, pin number 8 to ground. Okay, pin number 8 to ground. In between that, they have connected 3 resistance in series. Okay, 3 resistance in series. So here voltage is more across this resistance. Here voltage is very less compared to first here, and the resistance voltage is very less compared to this because voltage is flowing from ground to supply to ground, right? So for that 5 kilo resistance voltage is very less compared to this. Okay, resistance is same, but voltage is decreasing here. So here they have taken difference in voltage for the comparator. Okay, here they have taken higher voltage for the second comparator here. Here they've taken lower voltage for the first op amp. Okay, first op amp, what is input here? Positive sign. Here they've taken negative sign. Okay, here negative of the first comparator is connected to where here triggered. Means here we can apply the any kind of triggered input. Means we can apply the any kind of short pulse. Okay, then output of the first comparator is connected to flip flop. That is set mode. Then same thing, you take second comparator output. It is connected to flip-flop, that is for the reset mode. Understood? So next you take positive of the second comparator is connected to threshold voltage. Means you have to maintain some reference voltage here. From that you can compare this one. Same thing here also. For the first comparator, we can compare the signal with the triggered voltage and the coming supply voltage. Okay. Then you take output of the flip-flop, it is connected to the reset mode here. Then Q bar, it is connected to output here. Understood? Then pin number 5 is connected to controlling voltage for this second comparator negative sign. Okay, this is the circuit diagram here. From this IC, we can make a monostable multivibrator. Okay, monostable multivibrator. Here you take one example here. This is the monostable multivibrator circuit. See here, they have taken 355 timer circuit here. There are 8 pins, right? So R1 is connected to pin number 7 and 8 here. R2 is connected to pin number 2 and 4. Okay. Then here they're going to apply the negative triggered pulse. Okay. That is for the pin number 2 and ground here. Then they have connected capacitor in between the pin number 2, pin number 6 and ground. Okay. The pin number 7 and 6 are shorted here. Then capacitor is connected between the pin number 5 and ground. Okay, pin number 1 is connected to ground. Then output of the timer, it is connected where here? Pin number 3. Okay, pin number 3 is the output here. Understood? Pin number 3 is output here. So this is the complete circuit connection for the monostable multivibrator. See here, what is the operation of this one here? You take first triggered pulse as an input here. Okay, where is the triggered pulse here? That is pin number 2. Pin number 2 is triggered pulse. Here they have taken negative pulse here. Okay, in negative pulse, suppose voltage is below the 1/3 VCC. Okay, then capacitor start charging here. Okay, capacitor start charging up to 2/3 VCC. Understood? Remember this one here. When triggered pulse is less than the below the 1/3 VCC, then capacitor start charging. It start charging from 0 to 2/3 VCC. Because why? Because here pin number 2. Pin number 2 it is going to be here triggered. Okay, pin number 2 it is going to be triggered. That is this one here. But capacitor is going to be here pin number 6. Where is pin number 6 here? This one. Okay, this is the threshold voltage. Okay, what is the threshold voltage value here? 2/3 VCC. This point we are getting 2/3 VCC, and this point we are getting 1/3 VCC. Okay, they have taken two comparator, right? What is the input of the comparator here? One from the 1/3 VCC and one more from the 2/3 VCC. Okay, so capacitor is connected to pin number 6. Okay, suppose trigger pulse it falls below the 1/3 VCC here, then comparator becomes on condition. When it is an on condition here, that capacitor starts charging up to 2/3 VCC. Okay, see here, when trigger pulse it goes to below the 1/3 VCC here, then pin number 6 capacitor charges up to 2/3 VCC. That is the maximum level. In this condition, output voltage becomes a on condition. Okay, output voltage becomes a on condition. When capacitor start discharges here, okay, output voltage becomes 0. Okay, can capacitor start discharges suddenly here, okay, and the output voltage becomes 0. Understood? This is the monostable output. For more information about this monostable, we can watch the upcoming video that is on the model number 5 here. In model number 5, I'm going to explain complete 3x5 timer circuit operation. From that, we can understand how we got the monostable output, how we got the capacitor charging and discharging here. When triggered pulse below the 1/3 VCC. Okay, this is the small explanation about the experiment here. Okay, if you know this explanation here, then easily you can understand the operation of the monostable multivibrator. So next to take software here. Okay, in software I've taken circuit diagram like this one. Here I've made some arrangement for the monostable multivibrator. Okay, so first I've taken IC 555 timer here. The pin number 1. Okay, pin number 1 it is connected to ground. Okay, the pin number 6 and 7 it is connected to a capacitor. Okay, and it is shorted here. Okay, then pin number 4 it is connected to VCC value, that is 5 voltage. Okay, pin number 6 it is connected to R1 resistance. Okay, C1 is connected to pin number 7. Again, there we are going to apply the triggered pulse. Okay, that is for the pin number 2. So here they have taken V pulse. Okay, V pulse I have taken V1 is -10, V2 is +10, time period is 0, TR is 0, TF is 0, and pulse width is 5 millisecond. Then PR is 10 milliseconds. Okay, I have to give triggered pulse like this one here, -10 to +10. Understood? With the pulse width of 5 milliseconds. So here we can watch the output voltage from the terminal number 3. Then we can watch the capacitor charging and discharging from the capacitor. Okay, and then you can see the input voltage also here. So this is the complete circuit of the 3x5 timer. So next to take PSpice software here, select the components here, and go to place part. Okay, so take V pulse. Okay, if you take a V pulse here, we can give the voltages. Okay, we can give the voltages like V1 is -10, V2 is +10, TD is 0, TR is 0, TF is 0, pulse width is 5 millisecond, and PR is 10 millisecond. Okay, this is the voltage level for the not to give the pulses for the triggered input, pin number 2. Okay, then pin number 6 and 7 is shorted here. It is connected to capacitor, and pin number 3 is the output here. Okay, so make the circuit according to given diagram here. So already I've written the circuit diagram here. Okay, next you go to new simulation. So give the parameter like analysis type is time domain. Okay, choose analysis type is time domain. So analysis type is time domain means you can select the runtime as a 50 millisecond and start saving data after is 0 seconds. Okay, after that you can give the apply. Then okay. Then you run the PSpice here. Okay, before that you select the voltage marker, keep it across the output of the 555 timer, then input of the 555 timer, then pin number 6. Okay, after that you run PSpice. So once you give the run PSpice here, you'll get the output here. This is the output of the monostable multivibrator. Okay, here the red color is what here? Triggered pulse. Okay, where you apply the triggered pulse here, like -10 to +10. Then here the green color is capacitor charging and discharging across the pin number 6. Okay, or 7 here. Okay, so when capacitor start discharges here, the output voltage also decreases here. See here, the output voltage also decreases here. Okay, this is the stable. Okay, what you're getting that is higher on period, that is stable mode. Okay, what you're getting off period, that is 0 voltage. Okay, when capacitor is 0 here, the output voltage also 0. Okay, when capacitor is charging mode here, then output becomes a stable here, that is single mode. So this is the complete output of the monostable multivibrator using 555 timer.